In this question, we've been asked to differentiate f of x is equal to inverse sine of x. So the first thing we should note that when we see sine to the minus 1 of x, it means the inverse sine function. Okay, we need to be clear that when we have sine to the minus 1 of x, it is not equals to 1 over sine of x. Now this notation can be confusing, so I'll just say it again, that when we see sine to the minus 1 of x, it is not equal to 1 over sine x. It is the inverse sine function. So now to differentiate it, we're going to write that y is sine to the minus 1 of x, and we're going to take sine of both sides. So when we take sine of both sides, we'll get that sine y is equal to x. So now what we're going to do is differentiate both sides with respect to y. So that requires me to differentiate sine with respect to y. And on the right hand side, I'll just have dx by dy. So when I differentiate sine, we'll get cos, and we'll just have dx by dy on the right hand side. But I didn't want dx by dy, I wanted dy by dx. So I can use the inverse law and just flip everything over. So I can say that dx by dy is 1 over dy by dx. So that will tell me that dy by dx is equal to 1 over cos y. So I've now found dy by dx, but I've got it as a function of y, and as my original question, y equals inverse sine of x was all a function of x, I should find dy by dx as just a function of x. So what I will say is, using cos squared y plus sine squared y, which is equal to 1, I can say that cos of y is equal to the square root of 1 minus sine squared y. But I can also see that sine of y was equals to x. Therefore, I can say that cos of y is equal to the square root of 1 minus x squared. Now I can see that my dy by dx was originally 1 over cos y, but I can now write that as 1 over the square root of 1 minus x squared.